Good morning. Today we are going to be talking about compound inequalities. So far this week you've worked on solving inequalities and just looking at the basic notation of inequalities. And today we're going to extend that to what we call compound inequality. So let's get started. So the first question is, what is a compound inequality? What is it? Well, a compound inequality consists of two distinct, meaning two separate inequalities that are joined by the word and or the word or. Okay, so we have two types of inequalities, and inequalities or inequalities. Okay, so we're going to look at the and inequalities first. Okay, so an and inequality might look like this. X is less than 7 and x is greater than 3. Okay? And the way we graph this is we first graph x is less than 7. So what we're going to do is I'm going to make a number line, and we're going to, so let's call this 7. That would be 6, 5, 4, 3, 2, 1, 0, 8. So this is my number line. Now, if we go and graph x is less than 7, what kind of dot is less than 7? Remember, less than means an open dot. So we're going to graph an open dot. Okay, so I'm going to do this one in red. So I'm going to graph an open dot at 7 and less than. Give me an example of numbers that would be less than. 6, 5, 4, 3, 2. Everything in this direction would be x is less than 7. Okay, then let's graph x is greater than 3. Well, again, we have an open dot because it's greater than, not equal to. So I have an open dot at 3, and greater than 3 would be like 4, 5. So we're going to graph it this way. Okay? And where the lines overlap is what our solution is. So if I were to look at the actual solution of this compound inequality, my solution would look like this. Okay, so I'm just going to redraw a number line. And what I'm going to do is I'm going to take the parts of this inequality where they overlap. So this is 7, this was 3. And the parts where they overlap, I'd have an open dot at 3, an open dot at 7, and everything in between. Now I'm just drawing a squiggly line because it's hard to see this yellow on top of that. So this says x is both less than 7 and x is greater than 3 at the same time. Okay, this is called a compound inequality. Now, we can write this as one inequality, meaning one statement where we don't have to have the word and in between. And is unique this way. And the way we do that is any place that I have a line, or this line represents x. Okay, so I'm going to stick x in the middle. Do you agree x is in the middle? And then the biggest number I have is 7, and the smallest number I have is 3. And when I want to write the inequality, I am going to put the inequality that says this. So it's going to say 3 is less than x is less than 7. Okay, so I didn't actually change any of the words or any of the inequalities that were already in my problem, because look, remember when we did the intro to inequalities, we talked about that we can rewrite our inequalities as long as we keep the mouth and the point consistent. What I mean by that is, this says x is less than 7. Notice the point is pointing to x and open to 7. Here, notice in here that it says x is less than 7, so the point's pointing to x, open to 7. Additionally, I had x is greater than 3. And notice that the mouth opens to x but points to 3, and here the mouth opens to x and points to 3. Okay, So this is a special way to write an and inequality. Okay. So let's look at what or inequalities look like. Okay, so we would see in the problem, it would say x is greater than 4 or x is less than negative 1. So let's go ahead and graph x is less than 4. I'm first going to draw my number line. This one needs to have a negative 1 in it. So let's call this 0, negative 1, 1, 2, 3, 4, 5. Really on a number line, you don't need too many numbers. We really just need a couple numbers on either side of what we're actually graphing would be fine. And I just typo on here. So would you go ahead and let's change this. This should say, I'm going to cross that out. This should say x is greater than 4. And this one should say x is less than negative 1. Do you see what I mean? It needs to match what's up top. So I mistyped that. Okay, now let's go and graph these. So I'm going to start with the x is greater than 4. Open or close dot? Hopefully you said open dot. So we have an open dot at 4. And give me an example of a number that's greater than 4. 5, 6, 27, 38. So all of my numbers go towards the right. They go towards those bigger numbers. Okay, so let's do the same thing for x is less than negative 1. Open or close dot? Yep, it's an open dot again. So I'm going to put an open dot at negative 1. And all of my numbers need to be less than negative 1. So negative 2, negative 3, negative 4, and so on. So this is going to come down this direction towards negative 2, towards the left. Okay. Do these lines overlap? No, and they shouldn't, because this is an or problem. And because this is an or problem, I don't want where the lines overlap. In an or problem, I'm just looking for the combination of both sets of answers. Okay? And you'll notice there's not a special way to write an or inequality. All I can really say is or. I can say x is greater than 4 or x is less than negative 1. So I don't have a fancy way to write it like I did with and. Okay, let's try some. So the first thing that you should do when looking at these problems before you actually begin is first ask yourself, okay, is it and or is it or? So maybe highlight for yourself the or and the and. The or and the and. So we've got or and and. That one doesn't have it. So what is this one? Even though it doesn't say, what is this one? This third one. Well, this is and. So if we highlight that to remind ourselves what we're looking at. Because and means overlap. So we'll come back to that. So let's try this first one. If I want to graph x is greater than 7 or x is less than 0. So I'm going to label my number line 3, 4, 5, 6, 7. Okay, I know all those other numbers are in there too. You don't really need to label them. But x being greater than 7, I'm going to have an open dot at 7, and I'm going towards the right. I'm going towards 8 or 9 or 10. And then, if I do the same thing with x is less than 0, I'm going to graph an open dot, and less than 0 would be like negative 1, negative 2, and all of those. So I do have an or graph, and my or graph is going in opposing directions, and that's okay. Now, what is it I'm looking for on an and graph? Remember, on an and graph, when we see the word and, we want to think the overlap. So I'm trying to figure out where they overlap. So let's put some numbers to this. So we're going to start, let's do negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We really only need a couple numbers. We know all those numbers in between are there. Now, x is greater than 0 or equal to, ooh, we threw in a wrench. X is greater than or equal to 0. What does that equal to do? What does it change? Right, that's the dot. It's going to be a closed dot. So this says X is greater than or equal to 0. Now I'm going to put this graph just above the graph. And this line goes this way. Because greater than or equal to 0 would be like 1, 2. Okay, let's look at the next one. This says X is less than 9. So I'd have an open dot at 9. And numbers that would be less than would follow like 8, 7, 6, 5, 4, 0, -1, etc. Okay? Now, when we look for the overlap, and the reason I drew the graph above it is because then I'm going to put a closed dot and an open dot on the two places that I have for mine. And then my answer is everything that's in between here. Okay? If you remember, this problem could be rewritten with X in the middle, 9 on the high side, 0 on the low side, and I'm going to keep my mouth the same and my point the same on each of my inequalities. So this 0 is less than or equal to X is less than 9 says the same thing as X is greater than or equal to 0 and X is less than 9. Okay, I want you to hit pause and I want you to try the next two examples. All right, hopefully you had a chance to try these examples, and I'm just going to go ahead and label my numbers 0, 1, 2, 3, 4, 5, 6. Maybe put an extra one there. And I'm going to see that this says and. So this is an and graph. We wrote that. Remember, we have this written in this fancy way. And I see at -2, I've got a closed dot. So I'm going to put a closed dot at -2. I know it's closed because of the inequality sign. And I'm going to put an open dot at 6. And the X value is going to be everything that's in the center, the overlap. How'd you do? Okay, let's try the OR. Let's see how you did on the OR. So let's label this. Oh, these are big numbers. So let's go -13, -12, 11, 10, 9, 8, 7, 6, 5, 4. And somewhere up here we have 0, 3, 2, 1. Okay, so big number line. All right, so the first one says X is less than -12. So less than is an open dot, -13, -14. Those would all be less than 12. And then X is greater than or equal to 4. Oops, sorry, -4. So I have a closed dot at -4. And greater than would be like -3, -2, 1, 0. It's going this way. And since this is OR, I'm just looking for the combination of both graphs. So this is my answer. How'd you do? Okay, let's keep going. Okay, now that we have the basic idea of what a compound inequality is, we are going to extend that to solving inequality problems, not just graphing a simple inequality. We're going to look at more complex ones. So we're going to start with and I'm going to give you a couple helpful hints with and. First, we're going to solve it even if it's written in this simplified notation. We're still going to be able to solve this all at one time. And actually, I think the solving of this one type of problem can go a little bit quicker than an OR. Okay? We're going to do it just like we would an equal sign. And we're going to draw a line on each inequality like we would on an equal sign. And then what we're going to do is use the same steps we normally would to get the variable by itself. So we're going to use inverse operations. You just have to do it to all three columns. So here's what that looks like. Okay, so this first problem. I'm just going to draw some lines down to remind myself that what I do to one part of my inequality, I need to do to all three parts, not just two parts this time. Okay, so if you saw the problem m minus 4 equals something, what would you do to get the m by itself? Hopefully, you say you'd add 4. So when I add 4 here, to undo it, to use the inverse operations, I'm also going to add 4 to the 1, as well as to the -3. Okay? And in doing that, I get m The inequality sign does not change. I did not multiply or divide by a negative. So I get m is less than 5 or greater than or equal to 1. So here's what my inequality reads. Negative 1 is less than or equal to m, which is less than or equal to, just less than 5. Okay, well now I can graph it. I don't even have to graph 3 graphs on this one because I happen to have my answer all written out really nicely. So I know that this one, let's see, let's do 0, 1, 2, 3, 4, 5, 6. My number line didn't get very straight. But I know on this one that I have an equal to sign with the 1. So I'm going to put a closed dot. So closed dot on 1. I'm going to do an open dot on 5. And because m is between 1 and 5, the line that I'm going to draw is right here. Okay, here's what that line means. And we're going to look at checking this because this line says that any place I have a line, that I have a solution. So let's just verify that that's actually true. So let's check our work. And I'm going to check it. Let's do it in black. So let's pick a point that's in that shaded line. So I'm going to pick, let's just say 2. So we're going to let m equal 2. Okay, so we're going to go into our original inequality. And we're going to plug in m equals 2. And I'm going to check it. So this I get negative 3 is less than or equal to negative 2, which is less than 1. Is this a true statement? Is negative 3 less than or equal to negative 2, which is less than 1? Yes, that's a true statement. So I know that my solution in this region is correct. Okay, hit pause and try solving the next one. Okay, hopefully you came back and we can look at this. Okay, so what I do to one side, I'm going to do to the other. Now, this one's a little bit more complicated. So when I start my inverse operations, I'm going to start by multiplying all 3 sides by 2. And in multiplying all 3 sides by 2, I get 2 is less than 2x minus 7 is less than 10. Okay. Now I'm going to undo the minus 7 by adding 7 to both sides, or all sides. Well, this one's not pretty. So we get 9 is less than 2x is less than 17. And now what I'm going to do is I'm going to divide each side by 2. We get some not pretty numbers. So whether we use fractions or whether we use decimals is up to you. But if I look at this, this is 4.5 is less than x is less than, that will be 8.5. Okay, so let's look at what that looks like on a graph. 4, 5, 6, 7, 8, 9. We'll call that 9. We'll call this 4. So 4.5 would be somewhere in here. It's going to be an open dot. 8.5 is in here, open dot as well. And everything in between is a possible solution. So I could check any number in there in this region and it should work. So I could check 5. I could check 5.3. I could check 6.267. I could check any number in here and it will make this statement true. How'd you do? Okay, let's move on and look at ORs. All right, when we look at the OR inequalities, there's some helpful hints for graphing ORs or solving ORs. You are actually graphing or solving 2 separate inequalities. We don't combine them the way we did with the ands. So we're looking at 2 separate inequalities. Okay, so when I solve it, it's like I have 2 problems I've got to do, 2 for 1. Okay, so let's begin this first one. If I were to solve this first one to get x by itself, I would subtract 2 from both sides. So we get 3x is less than negative 9. Then I would divide both sides by 3. Notice I'm not dividing by a negative. There is a negative over here, but what's attached to the x is not negative. That's going to change on this next one. So I'm going to divide both sides by 3, and we get x is less than -3. Okay? Keep that there because the next one I'm going to do, and I need to remember this is an OR problem. The next one I'm going to do, I'm going to go through and solve this much the same way. So I'm going to start by subtracting 5. And we get -4x is less than -4, because 1 minus 5 is -4. Now, put a star by this one to remind yourself that this one's a little bit funky. That star is a little bit funky. Okay? Because when I go to divide by -4, what do I need to remember to do? If I'm dividing by negative, what do I need to remember? I need to remember to flip the inequality sign. So this says x is, and instead of saying less than, it's now going to say greater than 1. X is greater than 1. So I've got -3 and 1, so let's put those on my number line. Let's do -4, -3, -2, -1, 0, 1, 2. And when I graph these, remember, or we just graph both inequalities. So if I graph x is less than -3, I have an open dot. Let's do it in a different color, shall we? I have an open dot at -3, and it's less than, so it's -4, -5. And for the next one, I have an open dot at 1, and it's greater than, so 2, 3, 4, and that's my solution. So, hit pause and try this next example. Okay, let's go through this one pretty quickly. I'm going to draw in my lines, and I'm going to work to solve each of these. First, subtracting 7. So we get 5y is less than or equal to -10. Divide by +5, so there's no need to flip my inequality. So y is less than or equal to -2. Or, now go through and solve this one. So I'm going to draw on my line. I'm going to add 2 to both sides. So we get 3y is greater than or equal to 15. Divide by 3. Y is greater than or equal to 5. And so now I'm going to put them on my number line. 0, well, let's do -3, -2, -1, 0, 1, 2, 3, 4, 5. Maybe 6 in there. 5, 4, 3, 2, 1, 0, -1, -2, -3. So when we have y is less than or equal to -2, I'm going to put a closed dot at -2, and I'm going to go less than or equal to. Then when y is greater than or equal to 5, I'm going to have a closed dot at 5, and I'm going to choose numbers that are bigger than 5. How'd you do? Finally, I want to look at how we could write real-world problems as compound inequalities. In fact, we see this a fair amount. So let's look at a couple examples. The first one, the low-high temperature each day in November was either less than 40 degrees or greater than 65 degrees. Okay? Notice the word in here, or. Okay? See the word or? So that means I'm going to write two separate inequalities that are separated by the word or. So the first one says the low-high temperature for November was either less than, oops, I meant to be in a pen. Let's erase that. I don't know why it's not erasing it. Okay. Less than 40. So let's call it T for temperature. So this one says T was less than 40 degrees. Or, and that or is important, it was greater than 65. So the temperature was greater than 65. So let's look at that part. So T was greater than, not equal to, greater than 65. That's a compound inequality. That simple sentence is a compound inequality. So try the next one. Hit pause, try it, and let's come back and see how you did. Okay, this problem says the age of students in this class are greater than 12 and less than or equal to 16. Okay, greater than 12 and less than or equal to 16. That and is important. So let's say age of students. We'll call it A. The age of the students is greater than 12. And the age of the students is less than or equal to 16. This is one way we could write it. Did anybody write it a different way? Hopefully you remember that we could say the age of the students is between 16 and 12. Would be another way that we could say this. Okay, so that's compound inequalities. So now you have a Math Excel assignment on compound inequalities. We'll see you tomorrow.